Thanks for
Cool.
joining us at the AWS Cleveland User Group today. We're excited to have Mike McCabe with us. He has spoken several times for the DMV User Group, which is our sister user group based in the DC area. Mike, you want to give us an intro?
Sure. Thanks for having me today. Looking forward to talking about a topic that's, very near and dear to my heart and a lot of experience working in this area. But I'm the CEO of Cloud Security Partners in the DC area. Do a lot of work in the cloud security, preventative and reactive space for companies. And going to talk about some of the things I've seen, learned, and been through in cloud breaches.
Awesome. And tell us a little bit about CSP. What do you all do there?
Yeah, so we're a cloud and application security focused consulting group. We work with companies across the board, small and large, to help them understand their technical risks in their applications, their cloud environments, their networks, and everything in between, and help them remediate that risk from pen testing, code reviews, threat modeling, developer training, up to building out cloud environments for folks looking for a secure cloud environment. We do a little bit of everything for our clients to make them more secure.
Very cool. All right. Well, why don't we go ahead and have you share and we'll go on mute. If anyone has any questions, please put them in the chat or raise your hand virtually at the bottom of your screen.
Cool, thanks. So today is how to prevent cloud breaches. Little foreshadowing. Not sure if you can completely. I'd love to give you the magic that there's one thing to do. There's three things to do to prevent these. We're actually in the middle of a couple incident response engagements right now with companies that had their clouds breached, and I'll talk about kind of how some of that actually happened. Not naming any clients, naming any names, but talk about what's actually happening in a real world environment right now. So it's very poignant for us and very poignant for what people are going through. So again, intro, Michael McCabe, CEO of Cloud Security Partners. I started the company about 10 years ago. We've worked with hundreds of clients on all types of engagements, but our focus is really around securing your environment through testing, because testing is an important part of understanding what your risks are, but really helping with remediation and making sure that we fix those risks. And that's, like I said, through developer training, through code reviews, through pen testing, even helping our clients fix their code if needed. We've written code and published it to production for our clients around security issues when they didn't have the in-house expertise. So we have a team of engineers that's very well versed in both security and engineering and comfortable to help out that level. Some of our experience that informs this talk, over the years, we've done thousands of cloud assessments against our clients' environments, against AWS, GCP, Azure, everything kind of across the board, even Oracle, even Alibaba here and there. And we've seen a lot of what is commonly misconfigured and what's kind of wrong in cloud environments. We've also done hundreds of incident response engagements. This is when you're brought in by a law firm or an insurance carrier post breach, and you're meant to help the client understand what's the data impact, what was stolen, how was it done, and how do they fix those issues, and what is their kind of liability with the data that might be lost or the systems that were down, things like that. It's really interesting working on both sides of the fence, because on the proactive side, we try to help people prevent these kinds of things from happening. We do those assessments to understand their risk, and then on the IR side, we're seeing what goes wrong for folks when they haven't done kind of the right steps, which is very difficult to do. No one is ever perfect. No one's ever completely secure. But we commonly see a lot of common issues that lead to these breaches, and it's nice to kind of understand both sides and to see how threat actors actually exploit these issues, not just kind of think about it theoretically. So I'll talk about kind of how that experience leads into what I'm talking about today and the things we've seen and what to do about it. So like I said, we're going to talk about some of the common causes of breaches, the techniques, and then definitely focus on how to prevent it. I want folks to take away from this some very tactical steps they can take today to actually make their cloud environment more secure. That's our whole ethos as a company, is to actually make people more secure, not just talk about it, not just provide reports, but actually help them become more secure. So I definitely want everyone listening to get an idea of what they should be doing today. And one thing I want to say, kind of what is cloud in 2025? We used to think it's just AWS or it's Azure, it's GCP, those kind of infrastructure as a service platforms. But I think cloud has really evolved over the past, I'd say, 5 or so years. We're seeing so many more breaches outside of just the typical cloud providers that folks are moving infrastructure into. There's been a lot of stories recently. One just the past week that Google put out around Salesforce. I'll talk about another one that Google also did a bunch of research around. But we've seen, Snowflake targeted, Databricks targeted. So I'm going to talk very specifically about AWS today, but I do want people to think like cloud is more than just those three providers now. It's everything from your data platforms to even things like GitHub are almost a self-contained cloud. They have compute with runners, they have storage, they have secrets. They can be hosted in your environment, it can be hosted outside of your environment. So the cloud is expanding quite a bit in 2025. It's not what we traditionally thought. So we have to think kind of bigger when it comes to our cloud security plans. And some stats. Every talk needs a couple stats. I think this is an interesting one. This is from an IBM report. They started putting out a report on the cost of breaches, which I think is really interesting. A little sad, but also really interesting because it's actually breaking down what does it cost a company when they go through a breach. So the global average is 4.4, but I think the US average is actually something between 7 and 9 million. So, probably talking to mostly US based folks. A data breach in the US is even more expensive, obviously, due to all the compliance regulations, all the states that are going to, reach out to you and say what's going on. And obviously lawyers are so expensive. So, but data breach costs are very high. And one thing I always want people to think about, having been at a company that had a data breach and also seeing it from the outside as a consultant helping companies through it, the amount of time, focus, and effort that the company has to put into, addressing it and then remediating the breach, really, I think even these numbers kind of underplay how expensive it is for a company. When I was at a company that went through a data breach, it was 6+ months of work for the company, and everything was just kind of frozen during that time. You spent most of your day answering questions from state's attorneys, federal organizations that want to know what happened. So it's a huge distraction for companies. So even beyond what you might pay in lawyers' fees and instant response fees and insurance deductibles, you're also just going to have to think about like the impact of what a breach means to your developers, your engineers, your product folks, day in and day out dealing with these issues. So the costs are really high in multiple ways.
Mike, I wanted to throw down on that. The other thing is
Yeah.
reputation cost, right? Like,
Yes.
the damage it does to your customer base and their confidence in you, you almost can't put a number on that.
Yeah, I don't have a slide on this, but one of the Salesforce related hacks recently was a company called SalesLoft that is an integrator, and they have access to a lot of client Salesforce instances, and they were hacked. It's almost a supply chain attack where they were hacked to get access to Salesforce because Salesforce has a bunch of data for clients. This isn't a breach of Salesforce itself. It's more of a breach of a system that had access to Salesforce, but they're just being dragged through the mud. I mean, Google is writing multiple blog posts about it. They've had some researchers just focus on the Salesforce issue for a while, and I'm not sure what will happen with that company, but for the next year, they're going to be in a really bad place to try and recover their reputation, like you said. So ironically, I'm going to talk about Google and how they got breached, still related to Salesforce. But even in the last year, we've seen some huge breaches from really large brand names. And anyone who's worked in security or engineering, these companies have really big security teams. I used to work at a financial, it was over 500 people in cyber and risk these companies invest millions, tens of millions in security, and breaches still happen. So it's a pretty big issue even for the largest companies. And Google has some very, very smart people, cutting edge security researchers to help in this area, and they still had an issue. So again, this kind of goes back to Salesforce. This has been a hot topic in the news recently, so I want to talk about that for a little bit. But they suffered a data breach with their Salesforce instance. And I think the funny thing is, you think it's Google. All right, was it China? Was it Russia? Was it North Korea that hacked them? Did someone use an amazing zero-day vulnerability that they couldn't have possibly known about to get access to it? Or was it a bunch of 20-year-olds social engineering people who had access to Salesforce? If you guessed the third one, you'd be right. Um, there's a group that's getting pretty infamous these days called Shiny Hunters. They're a threat actor group that's been around for quite some time. They've kind of changed names, changed techniques, but they've been hitting a lot of really large corporations over the past 5 or so years. And they've been focusing on Salesforce as a big target. Again, not targeting Salesforce, the actual company, but instances that companies run. And anyone who has worked in the enterprise knows just about everyone uses Salesforce for something or other. And so this isn't even a truly technical attack. All they're doing is calling up people who have access to Salesforce instances, phishing them or social engineering them to run a tool called a data loader, which there's a legitimate version of that to move data within Salesforce. They are giving them a malicious version, and that basically allows them to exfiltrate the data. So it's not some 0 day. They're not finding a memory corruption issue. These folks are calling people up and just convincing them to run a application at a privilege level and just dumping data out. And again, Salesforce usually has very sensitive data within it. So this is a really big issue when this happens for companies. And the irony about this is uh, Google did a really big blog post, and I have it linked to my slides, did a really big blog post about this issue and how Shiny Hunters has been attacking people's Salesforce instances, and it was really bad news for Salesforce. I have a good friend who, had to deal with a lot of these things, and he's on the other side of the phone from customers, very mad. And then about a month after they published that blog post, Google found out they had been hacked by Shiny Hunters. The same issue that they were, blogging about people being targeted. One of their Salesforce instances was targeted for the exact same method. So the irony is they published all this blog post saying people are getting hacked. They were hacked, didn't even know it until later when Salesforce alerted them. Then they updated their blog post to be like, hey, we also got hacked. So, it happens to the best of us. So how do these things happen? I'm going to kind of categorize them in three, but really four things. And complexity is something that kind of underlies all of these issues. So it's kind of the underlying issue. But what we see generally is misconfigured IEM, public data stores, and human error. Human error is kind of one of those things where leads to these issues as well. But like I mentioned in the Shiny Hunters example, the human error is really people trusting someone who calls you up and tells you to run some random software on your laptop and trust it to access Salesforce. But I want to talk about IEM first. And this is very tailored to AWS, but there's similar issues across the board with GCP and Azure as well. In AWS, in IEM alone, there are at least 10 or so different services you have to be familiar with and you have to configure correctly. So classically, we've had the issue with people using IEM users. They have hard-coded access keys. They accidentally push it up to a GitHub repo or somehow expose it. Someone was telling me a story about, a customer that even published it to the front end of their UI, and they, you could just look and view source, and that access key was right there. So just those alone are have been very tricky for people over the past 10 or 15 years of AWS existence, and we're still having those issues. We do a lot of assessments and we see people still utilizing IEM users. We look at the access key age. We see, oh, it's been 600 days since that access key is rotated. And really, we need to get away from using these at all. And I'll talk about that a little bit. But one slightly annoying and ironic thing is AWS itself has been pushing really hard to get people away from using IEM users due to the long-lived credentials problem. And they just released a new feature around Bedrock, their AI service, which pushes people to actually use IEM users tied to Bedrock with long-lived credentials. So I've done all this work to move to federation and temporary credentials, and now AWS is even publishing something to push people back to creating long-lived users with access to Bedrock. So a lot of issues in this area still, and that's only one aspect of IEM. Obviously, there's so many more. We see misconfigured roles and cross-account roles quite often. I think probably the thing that we see people struggle the most with is just overprivileged roles. And for a lot of folks, it's kind of an invisible issue where they code up a policy. It has service star star on it. They don't think about what the impact is if that if it's an EC2 or a Lambda or something that has that policy on it. What happens if it's breached or if someone has access to publish code to it? Similar to what happened with a large financial in the area years ago. But it's just one of those issues where people really struggle to create, privilege of least policy of least privilege access. And I'd love to say there's one easy solution. It does take a good amount of work to actually make these very trimmed down policies, but it takes a concerted effort by folks to actually build them. But it is well worth it because if you do have that breach where an EC2 instance is breached or Lambda or something like that is breached and it has a policy tied to it, if that has a very strict limited access policy, so it can't access all of S3 or all your RDSs or all your Dynamo DBs, the damage is going to be much more limited than if it has S3 star on it. So, but people are still struggling with misconfigured IAM. I think probably the most in our experience, and it's just a really complex system to understand and to lock down. And there's been a lot of breaches related to this. So one of them, which is a really interesting one, was this thing called Codefinger, where these folks, I think a lot of folks are familiar with ransomware, where basically someone comes in, they encrypt all of your systems, your hard drives, your AD, and then you have to pay to get the key to unlock it. It's what's made Bitcoin so popular over the last 10 plus years for attackers. This was an interesting attack where this group actually, when they got access to your S3 buckets, they didn't download the data and then say, hey, give us a Bitcoin or we're gonna dump this on the dark web. What they do is they actually switch your S3 buckets, your own S3 buckets, to a locally sourced key. And what that means is all the data in S3 gets re-encrypted, and there's no possible way for you or for AWS to unencrypt it. AWS doesn't have the key, you don't have the key, only this attacker has the key. So it's kind of a crazy thing where your data is sitting right there in your own S3 bucket, but it's now encrypted and you can't get access to it. Unless you can break AES 256 and higher encryption, your data is basically stuck until you pay the ransom. So these groups are getting much smarter about how they attack people. It's much easier to just encrypt your data in place, say, give us 5 Bitcoin and we'll give you the key to unlock it, versus trying to encrypt all your hard drives or download all the data and then delete it and things like that. There's another article, and this is all in my slides as well for folks to review after this, but there's a group, Shiny Nemesis. Shiny seems to be a popular term in the people who name threat actor world. But this was a really large scale cloud focused threat actor operation where these researchers actually found the infrastructure for this group. And the thing with threat actors is you never really know who's part of one, and they bleed together sometimes, and they build up, they shrink down, they go away, they come back as new teams. So, shiny hunters and shiny nemesis probably have some overlap. But it's hard to track who's who and who's doing what. But these folks were doing a huge amount of crawling the internet, and what they were finding was a ton of .git files or backup files, or the AWS folder from people's local systems. They were basically scaling the internet to find all these things, and then they had access to all these different systems. And this was found out not because they ransomed information or they did a big public announcement. These researchers actually found their infrastructure, found thousands of records of what this threat actor group had found in customers' environments, in clients' environments. And so it just revealed how much these threat actors are becoming very smart about how to get access to cloud environments and really like what to target. And they're doing it at scale. And that's, without even talking about how AI will enable this more as well. So two interesting stories, very focused on the IAM side of things. So some things to think about of how to prevent these issues. So I think the biggest thing is move away from long-lived credentials. If right now all your users log into all your AWS accounts, with an IAM user or with console logins, things like that, try to move away from that. AWS has done a huge amount of work with AWS organizations to basically give you the ability to create an organization and manage things at the organizational level versus trying to do it at each individual account. And with that, you can set up something called Identity Center, which is basically SSO for your AWS environment. It's really simple to set up. And you can manage all your users in one place. You can set permissions at that place so you're not managing policies on every single account. And you can even tie that into your IDP, if that's something like G Suite, or if it's Okta, or if it's Entra ID, depending on where you manage your users. Then you can just manage all of that AWS access from one place, and you don't have to go in and add users in every single account. And this gets you away from having those long-lived credentials that people will hard code into scripts or have living on their local environment. They can just assume a role locally through Identity Center, and then have short-term access to the environment that they need. It's a really useful tool. It's also free from AWS. You don't get charged for it, so it's not like it's an added cost. Obviously, there's commercial options like Okta as well, and a few other smaller players out there. So there's a lot of different ways you can do this. But even if you're a small company, you don't have a huge amount of resources, I definitely recommend moving away from using IAM users at all. So the other thing that's kind of overlooked that's really powerful that AWS has been doing a good job of over the past, I'd say, few years is they're building these things called IAM conditionals. And what they are is basically statements in IAM policies that say how a role can be used. So there's some really interesting things you can do, like restricting the usage of a role to a certain VPC or a certain org ID. And they keep adding more and more of these conditionals, which makes it even more powerful. And there's the concept of a data perimeter where you build up these conditionals and you build all of your roles, say your EC2 roles, your Lambda roles, whatever it might be, and you put those boundaries on them to say, all right, whatever role that my resources are assuming, they can't be used outside my VPC. They can't be used outside my org. And you don't have to do anything besides define the policies and these conditionals, and AWS does all the enforcement for you. So they're really powerful for machine roles. You can do the same thing with conditionals around user access as well to kind of reduce the blast radius if someone gets access to something. Often what we see is, and we saw this with one of the large financial hacks, was someone got access to an EC2, they hit the metadata service on the EC2, they got the short-term STS credentials through a web application vulnerability, they use those outside of that EC2 in their own laptop, they're able to pull a bunch of data from S3 because there's nothing restricting those credentials from being used outside of the VPC or outside that EC2. So had they used IAM conditionals, which didn't exist back when that breach happened, but if they were using them, they would have prevented at least that type of attack because those credentials were useless outside of that VPC or org. So those are really powerful and very much overlooked. And the last thing that's pretty obvious, enforcing MFA. You can do that easily in Identity Center. You can even do that with access keys if you do have long-lived IAM users, but always make sure that you enforce MFA across the board. We're still seeing, it's way too common, but we're still seeing root accounts without MFA for certain customers. So, these were best practices over 10 years ago. Obviously, still best practices that some folks are still missing. So this is Identity Center. If anyone hasn't seen it, this is just an example, and you can see you have all your different accounts here, and all you have to do is log into your Identity Center, and you click either Management Console to log in as that admin or billing, or you can click Command Line, and you actually get temporary command line credentials you can use locally as well. So it's super simple, doesn't take long to set up, and a really powerful way to reduce blast radius with IAM users. And here's the conditionals I was talking about. So this one is an assume role in a policy, and it's basically saying the principal org ID has to be from the org of this role, meaning that whatever resource is assuming this role has to be part of that org. And like I said, AWS organizations, you can kind of group everything together, multiple accounts, all the resources in it as an org, and then things are tagged with that org ID. And if AWS IAM does an evaluation and says, oh, this principal is not part of this org, I'm going to deny it because I have this conditional string equals. So it's a really powerful tool, and you can go crazy with it and make it super strict, or you can start really wide and just reduce the blast radius of compromised credentials. I don't know if anyone can really chime in here, but shifting to misconfigurations, this is some Terraform code. Usually if I'm doing this in person, someone will chime in eventually about what's wrong with this. But if you look at the bottom of this example Terraform, this is an RDS instance. Terraform is an infrastructure as code tool if folks aren't familiar with it. But this is actually a pretty common issue we see where people define RDS instances and they make them publicly accessible. So that last parameter, publicly accessible, basically means that when the RDS is created, it's going to have a public IP that's on the internet. So we see this way too often still, and one of the big ways that we see people being breached in the cloud is through public data sources and misconfigurations like this. And I was doing some research after kind of writing up these slides, and I wanted to see, if I go to GitHub and I search publicly accessible equals true, how many examples of Terraform are there out there that have this set to be true? And it's 1.4 K files, so 1,400 files that have this set as true. I'm sure some of them are examples, some of them are test code. Not every single thing is going to be a production Terraform. But the hilariously sad thing is one of the examples that popped up right there is from HashiCorp, the people who create Terraform. One of their examples has publicly accessible equals true, which is just maddening. Because people go to these examples, they say, oh, HashiCorp wrote Terraform, they maintain Terraform. They must be doing this the right way. I'm going to copy and paste their Terraform example into my environment, not thinking about what happens, and then they make their database public. So then I went over to Census, which is a tool folks might have heard of, Shodan. It's another open source data tool that basically all day, every day, these tools are scanning the internet to find, they look at every single IP, every single domain, and they pull all this data together into a system where you can search. And so I did a search in Census. I looked at port 3306, which is MySQL. And how many examples are there of databases of just MySQL databases on the internet? It's like 3.5 million examples of databases on the internet. Now, some of these are going to be false positives. Some of these might have some kind of firewall in front of it, so they're like partially open but filtered. But it just goes to show like how many examples of people misconfiguring resources in cloud environments. And it's so easy to do because, again, you switch that publicly accessible from false to true, and you now have a public RDS instance. And we hope that you're, using IEM access versus username password to access it, but oftentimes people use pretty, bad passwords and credentials to access their resources. So yeah, it's a pretty prevalent issue. It's quite bad, and it's for some reason not getting better. I'm not sure why people aren't familiar with the easy ways you can misconfigure these resources. And just in case there's any doubt, I took one example. I just did a simple nmap on 3306, and you can see this is a wide open MySQL database. It has authentication on it, but you can sit there and brute force it all day long. Very few people ever do any kind of hardening to do like login lockouts after someone's brute forcing a username and password on our database. So it's a pretty big issue that we're seeing quite often. We do a lot of Terraform code reviews for our clients to help them define their infrastructure more securely, and that's something we see very commonly. So this was another story that came out a few weeks ago. I'm not sure if folks are familiar with this app called T. It was kind of like a forum for women, and the whole intent is to let them talk about like people to watch out for, bad dates, just not very nice folks that they know from the dating scene. One of the problems was to prove that you are a woman on this forum, you had to upload your government ID, which let me just tell you, don't trust any system ever with your government ID. If you get your credit card lost, big whoop. Like maybe someone charges a bunch to it, you call up Visa, MasterCard, whoever, you say, hey, my credit card was lost. They charge the merchant all those dollars. You don't pay anything. If someone leaks your ID, that's a much bigger issue. You can't easily rotate your ID, and there's tons of identity fraud that happens based on these things. There's a whole ecosystem of identity fraud that people basically take these types of details, they batch it up, they sell it for quite cheap, honestly, which is pretty crazy as well. So just never upload your ID anywhere. That'll be my one takeaway. But anyway, this happened, and this company did a pretty terrible job with their security. They were using a database called Firebase, which is a system from Google, which a lot of folks use for mobile development, and it's a really easy way to get going with authentication and data storage. But it's also really easy to make these public. And when I say public, I mean like completely public, like no authentication whatsoever. We worked on a case not that long ago where someone did the exact same thing, and they got pinged by someone to say, hey, I have access to all of your data in your Firebase because you never locked it down. So this was a pretty terrible worst case scenario where people had very sensitive information. They had, selfies, they had their government IDs, all linked to this public data store. Folks found it. Of course, it made it way to 4chan, which nothing good ever happens to 4chan, and so they were all exposed, which is pretty terrible. This is another example, and this is something, for a while it was almost kind of a meme, the misconfigured S3 bucket. I think there was a Twitter account that just shamed people for S3 misconfigurations and leaks. But this was a huge one where a Turkish airline had a huge amount of data sitting in a misconfigured S3 bucket. And this has happened to everyone. Literally everyone at some point has had a misconfigured S3 bucket that's public to the world. And this was pretty bad that it was an airline and it was a huge amount of data. And we've gotten better in some ways with this, but it's still a pretty common issue. I mean, AWS has tried to make it as foolproof as possible for folks to not misconfigure S3 and make it public by having like bucket level access controls, having account level access controls, having tons of warnings in the UI. And people still do this pretty often. So I think some things to do to think about to prevent these misconfigurations. It's a pretty big effort across quite a few different areas. It's not like you can't just implement one thing and consider it done. But I think one thing that really helps is despite the issues I showed with Terraform and people misconfiguring Terraform deployments, things like Terraform and CloudFormation can be really powerful because you codify all of your infrastructure. You get away from people going through the console and just clicking through and creating things. They're going to misconfigure stuff. Um, and the nice thing about Terraform and CloudFormation, they're just JSON or HCL documents that are very easy to reason about. Meaning that, you know, again, going back to the RDS instance example, publicly accessible equals true. It's very easy to write even a basic regex to say, all right, find me every example where publicly accessible equals true. Run it across all of my Terraform, find all the issues, go in, fix it, and make those databases not public anymore. So it's really nice if you are using something like Terraform or CloudFormation because you can write security tools or use open source tools to enforce those guardrails. There's a couple tools, one called SemGrep, which there's an open source version. It's a security tool that's kind of like grep on steroids. And there's a whole bunch of Terraform best practices pre-written for AWS and Azure and GCP. And then there's also a few projects. One is called TFSec, which is also open source. It has all these different rules built into it. You can download it, run it against your Terraform code base, and find a bunch of misconfigurations. Some of them are going to be pretty minor. You don't need to worry about it, but I can guarantee it's going to find one or two issues you should probably take care of today. For CloudFormation, there's also a tool called Checkoff that is open source and does similar things. So using those types of infrastructure as code tools is really nice because you can implement security controls really easily. So a couple other controls that are really powerful that are also underutilized are service control policies and resource control policies. Service control policies have been around for a while. And again, this is going back to the AWS org where you can implement service control policies or SCPs account wide or org wide and basically say like this thing should never be able to happen. So for instance, you can make sure that root logins never happen without MFA or root logins don't happen at all. You can completely limit it in that way. So these were created to basically allow you to do account or org wide security controls, and it's a really powerful tool. I will say it takes some time to build out the policies and to test them well to make sure you're not shooting yourself in the foot and not allowing yourself access to things you need to have access to. So AWS in the past couple of years has released something called resource control policies, where service control policies were kind of across all services, across all orgs and accounts. Resource control policies are very specific to a certain resource. They're only on a few different services right now, like S3 and a few other ones. So it's not every single service under the sun in AWS. But instead of managing service control policies across your org, you can set very specific resource control policies on resources, which is kind of nice. One big issue with service control policies is they get really, really big and really unwieldy. So it's hard to manage them at that size. So it's kind of nice to be able to break out certain controls into RCPs. So here's an example of an RCP where we're saying any S3 action, any S3 resource, make sure we're using TLS 1.2. Yeah, nothing too crazy. It's not even like that likely that someone would use lower than that, but it's an easy way to enforce these types of controls. And basically, this is kind of a set it and forget it control where you put this on your org and you can just make sure that every single time someone's accessing any S3, they're doing it over TLS 1.2. So they're really powerful tools for implementing security controls across the board. So I think the big takeaway for me too on these things is don't try to boil the ocean. Don't try to do everything at once. Try to find a few use cases such as logging in with MFA or sorry, without MFA or something simple like EBS encryption where you can say, all right, we're just never going to allow disabling EBS encryption across the board. Start really simple. Start on use cases you know will never be not true, and then build from there. You don't need to boil the ocean. You don't need to set 10,000 SCPs. Any will help with your security posture quite a bit. The other thing that we see very often, and this is really poignant for incident response, because in incident response, you're looking at the live environment, you're looking at maybe code bases, and you're looking at logs. 99% of incident response is where are the logs? How do I get access to them? How do I normalize them so I can see what's happening across, a CloudTrail log to an Nginx log and everything in between. And so often, clients do not have the amount of log data that they should. Either that means they don't have logs turned on. It's all too common to not see CloudTrail like truly enabled. They might have the history for 60 days, but they don't have an actual trail set up, or they don't have a multi-region trail, or they don't have a trail on every one of their accounts. Um, and if you don't have those logs, you just don't have them. Like they're not easy to dig up. You can't just go ask AWS, like, hey, give me my CloudTrail logs from 3 years ago. They don't have them. So when they're gone, they're gone. And most folks are very much, they don't think about the logs they need until they're in an instant response scenario and they're like, wow, I have no visibility into my entire environment because I never thought about what would happen if something went wrong. Um, so big takeaway is make sure you have logs turned on. Make sure at minimum in AWS you have CloudTrail turned on. Have it going to an S3 bucket where it can be archived for the long term. It doesn't cost a huge amount of money to put data into S3 and then archive it. So definitely turn that on today. Have multi-region, have an org trail if you have AWS organization set up. But yeah, that's an important one that we see misconfigured all too often. And the thing that I always recommend is as kind of a architectural review, think about your system. If it's a web application that's data is traversing from like an ALB or from CloudFront to an ALB to a Lambda or to an EC2 and like an Nginx server, trace through requests and see if you can answer these questions of who did what, when, where with the system, and how do they access things. That's really important when it comes to incident response. It's really important when it comes to debugging a lot of things, but when it comes to incident response, we're trying to figure out the timeline of when something happened, how someone got access to something, and kind of how they did it. What was their access method? So being able to track someone hitting your CloudFront with, Firefox version, whatever, that goes down to your ALB and you see the access request there, down to your Nginx, down to your, ECS web service that's actually responding to the request. That's a really powerful thing to be able to do because you can say, I have full visibility into my system. I can see from, the very first hit from that request all the way down to when my database responded with the data, what that entire query looked like. There's some tools, Datadog and New Relic and things like that that try to help with some of that. But since these different systems often aren't all logging to something like that, you don't usually get that much visibility without doing some work to get all the logs in the right place. A lot of folks can't afford, years and years or terabytes of data in Splunk, so that's another issue. But as long as you have these logs being stored for the long term, and by long term I mean 2 to 3 years in S3, and you can pull it back out of cold storage when you need it, that's the right place to be. You don't always have to have all your logs being in Splunk or a different type of SIEM all the time, but you want to make sure you have all your logs for these different systems stored somewhere so you can really answer who did what, where, how. The why is because they're trying to hack you always. But so this is an example where Microsoft, our cloud overlords, they had a really big issue, which was a really interesting breach, which had a huge impact and long-lived impact, where they they believe it was a Chinese threat actor found a memory core dump from an error that contained an Azure signing key, which basically meant the key that signed sessions for Azure was dumped in a memory dump because some error happened on that service. They got dumped out. People do, they look at those dumps to see, okay, what happened, what caused this, so they can try to fix it. And there's a couple, it was a crazy kind of happenstance that like the system that looks for that key in those memory dumps to make sure that it's not exposed because it's super sensitive didn't catch it, and then this dump was moved from a production environment to a non-production environment with that key, and then Chinese threat actors got access to those systems, pulled the key out, and that's how quite a few government organizations were actually breached, because they were able to sign sessions and access Azure as different organizations. The crazy thing about the logging piece is Microsoft didn't even have the logs going back far enough to understand exactly what happened. I think it was rotated in like 60 days or something. So they weren't able to 100% say this is what happened. They were only able to say this is what we think happened, which is just insane to think that Microsoft, of all people, uh, don't have the logs to do real instant response when something like this happens, when they run the infrastructure for every large organization and every government agency out there. But even they fell prey to just the lack of logging across their systems, and so they basically had to do what happens quite often in incident response, which is piece together what happened without having complete proof, or having kind of the smoking gun that says this is 100% what happened because we see the threat actor, doing what we think they're doing. They basically had to piece it together. So a pretty interesting story, crazy. Like a couple of things changed, and this wouldn't have happened. But again, it goes back to they didn't have the logs they needed. So this is something I always like to ask people is, so say you have an S3 bucket, there's sensitive data in it, say it's, your customer's PII, it's transaction data, something like that. Um, Somehow 3 months ago, it was made public. It sat there for 3 months. It's public. It's sitting out there. You don't have any access logs. How could you tell the impact of the data loss? And the answer is actually pretty hard. You can't say, oh, well, people access these files or they downloaded this data. Because if you don't have access logs and it's a truly public bucket, there's nothing logging that. That's not going to hit CloudTrail. That's not going to hit CloudWatch unless you have those access logs turned on. The best answer you can really come up with, as far as I've been able to determine, is you look at your billing data to see what does egress cost look like, and based on that, how much data has gone out. But even that doesn't truly tell you the impact of how much data, because someone could be downloading the same data multiple times, something like that. So again, these are issues of visibility that people don't always think about, and they say, oh, well, these are private buckets. No one's going to access this outside of an IEM user or a role. Then someone accidentally makes it public. It sits there for 3 months. No one's paying attention, and someone finds the bucket and just starts downloading data. And again, you're working with your incident response firm to put together a story of what you think happened, not actually knowing for certain what actually happened. And the bad thing about that is lawyers will generally tell you to err on the side of caution and over-report data loss, not under-report data loss, in case it's ever revealed that more data than you said got out. So, these are just things to think about of, are you sure you have visibility into everything that's happening in your systems? The answer, based on the work that we've done and seen in environments we've assessed, is generally no. But definitely have access logs turned on for any really sensitive buckets, even if you have them marked as private. A couple other things that we see that are very prevalent that I wouldn't say are truly cloud specific, but a ton of unpatched software. I think one nice thing in the cloud environment is we're using so many cloud services like SNS and SQS and S3 and Lambda, where patching, you're not really responsible for the patching. You're not patching your SNS version. AWS is doing all the work under the hood to keep that software up to date, at least in theory. But it still does happen where people host software, a lot of COTS products, a lot of VPNs, that they're not updating that software, and that leads to a lot of breaches. There's been a whole very ironic spree of VPNs and remote access software that's been breached over the past 5-ish years, which is terrible, but not completely surprising if you look at some of the code that those things are built on. Um, Along with that, we see a lot of supply chain hacks where people are going after everything from the open source tools you use under the hood. They're going to go after the companies that you integrate with or might have access to your AWS environment. So you got to think through how you trust those organizations as well. Make sure you're really thinking through what access they should and shouldn't have. Um, so covered quite a few things, but I think the big takeaways beyond what I've talked about is, breaches happen to everyone, large and small. I've worked with small organizations and I've worked with some of the largest financials that are insanely heavily regulated and have, auditors who are reviewing everything all the time. And even they have issues that are all too common. And so these things happen. Really, it's about how you build your environment to be as restrictive as possible. So when something does happen, the attacker has limited access and has limited ability to access data or exfil data or whatever it might be. So it's really about building those layers, the controls at multiple layers, and then making sure you can tell what happens when it goes wrong. There's no easy way to prevent all breaches. If I had that, Google would have bought me out for 32 billion like Wiz. I'm still haven't heard from them yet, so I don't have that silver bullet for you. But you have to think about how you handle getting breached, not only how you prevent getting breached. Another thing to think about is IAM is the new perimeter, meaning stop thinking about networks, stop thinking about firewalls, think about how your identity is really your access control method now. Previously used to think about like, all right, what's our firewall rules? How are we preventing SSH on the internet? And now we're thinking about, all right, how does someone access our S3 bucket if we misconfigure a policy? So you have to make that mental shift as well. I'm not sure if there's time for any questions or if there are any questions in chat, but I can take some.
Yeah, we do. Thanks, Mike. That was awesome. As somebody who used to work for a cybersecurity company, for all that is holy, please have backups, check them for ransomware, and make sure they're recoverable. Um, Scott, Ben, Certain, does anyone have any questions for Mike? And feel free to just come off of mute. We've got a small crowd here. All right, we get a shy bunch today. Oh, here we go. Then right now, great presentation. Thanks, Ben. Appreciate the comment. Mike does a fantastic job. Okay, well,
Thanks.
everyone, here's Mike's information if you want to get in touch with him.
Yeah, feel free to reach out. Always glad to talk shop. Also on LinkedIn, if you want to send me a message. Doors always open. Always glad to talk about these things. And yeah, thanks for joining. And thanks for having me.
Oh, Scott, did you have oh, okay. Just another comment on a good presentation. All right, thanks so much, everybody. Have a great rest of your day.
Thanks.